Okay, welcome to the next class for an IFR Ground School. My name is Dmitry. I have a YouTube channel and Instagram channel, Fly with Dmitry. I am a certificated instrument flight instructor, and I am posting this primarily for my students, but happy to provide this as a training material for anyone who gets access to this. However, please talk to your CFI. This material that I provide is not a replacement for your study or your CFI instruction. So disclaimer. So what we'll do today is we'll talk about the instrument approach, and I'll try to make it simple, and I will connect this with the actual programming of the GTN 650. Most of the airplanes we fly here have a Garmin GTN 650 as the GPS unit. It is often paired with G5s or a G3X, depends, but the core programming, all that you need to do and understand, lives inside the 650. So we'll look at that. But first, what is instrument approach? Quick refresher. I know we have a couple new joins who have not been through the previous classes. Instrument approach is a way to navigate below the weather. We are flying either in the clouds or above the clouds, but to land, we have to see the runway. So approach is a guidance to let us descend safely and see the ground. There are three types of approaches, mainly precision and non-precision, but then there's also approach with vertical guidance. Most often, the one we see in this category is the GPS approach to LPV minimums. For today's purpose, we will look at a non-precision approach, NPA. What different about non-precision approach? We have no vertical guidance. Typical examples are localizer, VOR approach, MDB, less common, and the one we'll look at today is an RNAV approach. And all those approaches use MDA, which is the minimal descent altitude. And that's critical, as you'll see later, to not descend below the altitudes you are given. So let's roll through this. Non-precision approach. Again, we navigate below the clouds. Pilot is responsible for all of that navigation. And very importantly, again, to watch those altitudes. If you descend too low too soon, that may run you into, as they say, cumulogranite, or otherwise known as mountains. So, non-precision approach. RNAV GPS 31 left, that's our local approach here in Hillsborough. We also have ILS or localizer, which we can use for both either ILS precision or a localizer only non-precision. Today we will look at the RNAV 31 left approach. Let's jump out and look at specifically at this approach. So what we have for this approach at Hillsborough. First of all, when you brief, I would always start with what the approach is. RNAV, GPS-based approach to runway 31 left. We look at the minimums. The way to simplify this is we only have LNAV minimums, and most places they would have this MDA, so minimal descent altitude. Look at category A. All you need to know is your minimal descent altitude is 660 feet, and -1 means you have to have 1 mile flight visibility. So really this whole minimum section, if you're flying straight in, comes down to this 660, 1 mile. The smaller number is the altitude above ground, AGL, but that's not what you're really flying. That's more for your situational awareness. You have altimeter set to local setting. You're flying down to 660 MSL, and on the check ride, you shall not descend below that 660 even a single foot, which means when I teach students to go for that kind of a check on the check ride, buffer that by 50 feet. So if you'd be flying, we'll set a minimum of 710 just to be on the safer side and aim for that. So 3-1 left at Hillsborough. Now, what I'll do next, and I'm still practicing this, hopefully it works, is I will bring a 650 alongside with the approach plate. And first thing we do when we go in to set up approach, say we have a flight plan, I'll go and clear this, start from scratch. You have a blank 650, and let's say you're flying somewhere a little bit southeast of Hillsborough. There you go. There's Aurora, Hillsborough, somewhere in that vicinity. Now, this puts us roughly about here on my PowerPoint approach chart. First thing you do when you want to load an approach, you go into the main menu, hit proc, select approach, make sure you select correct airport, start typing KH, and immediately you see the Hillsborough pops up because 650 is looking at the closest airport with the letters you are typing. So typically you just need one letter, KH, and the Hillsborough will be there. So then you click at Hillsborough here, click, and then GPS will, the GTN will give you options of ILS and GPS approaches. Scroll down, get the 3-1 left, done. Now, the next screen, very important, is you get to pick a transition. And this is where you have to have a plan in mind. How are we getting there? What are we flying? And there are a couple ways we can fly this approach. If you look at the chart, we have initial approach fixed flower. If ATC asks you, do you want to fly a full approach? And you tell them, yes, please, full approach from flower, they'll probably give you flower as a transition. In this case, click transition menu and select flower. Now, whenever you load an approach, do anything like this in 650, magic preview button, really your good friend. So hit that and you see where you are. Imagine we'd be actually flying south of Hillsborough, east of McMinnville, and you will see your location relative to the some of the fixes. So for situational awareness, if you mistakenly loaded some other airport or another approach and it makes no sense on preview, don't load that approach, obviously. But this one, you can scroll around and make sure that makes sense according to the plate. Yes. Question?
Dmitry, if I ask a question, it looks like you're more than 10 miles out from Hillsborough. Who are you talking to at this point?
Good question. Hillsborough is covered by Portland approach, and they would be your ATC somewhere between Salem and Hillsborough. I always forget how close. 10 miles out, more than likely you are on Portland approach frequency, yes.
Okay.
If you're flying from Salem, you'll start with Seattle Center, and then they'll throw you over to Portland approach at some moment.
Got it. And I shouldn't be establishing the communication then. I should be already on the frequency with them.
Well, depends what you've been doing. If you were on an instrument flight plan from some remote Eugene place, yeah, you'd be talking to them anyway. If you were just buzzing around and you decided to do a pop-up IFR, then you dial into the approach frequency that's responsible for the area. The simplest way to find that out, by the way, look on your plate, see in this second box, Portland approach, 1260. So that's your frequency.
Okay, thanks.
Within 10 miles, you're definitely in their jurisdiction. If you're 20 miles out, well, that things may change. Okay, so let's see if I can make it a little bigger. There you go. Okay, that should be bigger. So flower, and there are a couple other gray routes and a blue triangle. Those are feeder routes. see that Vance here has a thin line with altitude restriction, heading, and distance. It is called a feeder route, which could be part of your approach. You could get direct Vance as part of approach clearance, but don't confuse that with the initial approach fix. There are a couple differences. Same here for the Bonneville. That's another feeder route that could be used. On this approach, we have only two initial approach fixes, Flower here and Mules. Again, you're free to pick either one, and your request would typically be granted. But when you are requesting a full approach, you're picking one of those initial approach fixes. Now, go back to where I
question. How do I know that Mules is one of the initial approaches?
See in parentheses IAF.
Oh, okay.
You see my mouse moving, right?
Yeah.
Uh-huh.
I see now.
So yeah, that's good. Thanks for asking. IAF here is initial approach fix, and you only see two of them. Right. Then
okay, cool.
Say again?
No, go ahead.
IF is Nike. That's intermediate fix, and the FAF is the final approach fix. Okay, so that was one of the options how you can request an approach. Now another, and I'm back to the 650 screen. See, there is a Flower and Mules and Bonneville. And Vance. So the only options that you have as transition point is the feeder routes, Vance, Elkis here on the right, and the initial approach fixes, Flower and Mule. So those are all your options in A650. So I'm starting to tie these two together. What you see in the menu of 650 versus what you see on the plate. You can't.
Yeah.
If
I could sorry to interrupt. Let me know if I shouldn't interrupt. But
no,
what about Hopgo or Cookies? Why are they not on 650?
Yeah, good question. So Cookies is in a waypoint on a feeder route, and it's just happens to be not one of the transition points. You can select a transition from Bonneville and fly this feeder route all the way. And the other one, did you say Hogbu? Yeah, same deal. So it is a waypoint that is not an originating point for that feeder route. See the difference in those lines? They're thinner. This one, Elkes to Hogbu, and Hobgu to Flower, and then the rest are thicker lines. That's the difference between the feeder routes and actual charted approach paths.
Okay, got it. Thank you.
Now, another option could be is if you select vectors. And that in real life, that is the most typical way that we would fly an approach if you're actually trying to get below the weather and fly it. What that means is ATC will be vectoring you to the gate, which is at least 3 miles ahead of the final approach fix Intel in this case. So they will route you to intercept the final approach course somewhere just past Nike. Now, when I selected vectors, if I hit preview, I kind of see all the same picture really. But when I load this, what will appear on the map is a long, let's just do activate approach and go home and map. And now all that you see is a long, I believe 30-some miles pink line that you can say maybe like an extended center line of the runway. It goes far. It doesn't lead into any specific fix. See, it just interrupts abruptly here because I may be wrong, but I think it's about 30 miles that the GPS will plot you. So when you select vectors, what you get is a long path which helps you to navigate to that and intercept that and fly the rest of the approach. So we can do that for the practice sake. Okay, so let's go back to the flight plan. What we did is we went into the procedure, selected approach, and I used vectors as the transition here. Pick the vectors, load and activate, and here is the flight plan. Now, here are the couple interesting things. See how Intel is has an arrow going to, but there is not a leg that is active. When we select vectors, the system will try to figure out what are you flying to. This simulator, one cool thing about this is allows you to actually fly the plane, and I can put it in manual mode. Go back, manual mode, and we'll change a heading to make it 050. So what I'm doing is I'm spinning this airplane on the map around so that we can simulate how the GPS reacts to us flying this approach. There you go. So make it a little faster. Now, I'm trying to point the airplane ahead of the flower, and when ATC will be vectoring you, they will give you a vector within 30 degrees of the approach course, which, if you look up here, 308. That's one important detail to remember and to expect. They can vector you around for as long as they need, but the last vector will be within 30 degrees. In this case, maybe within 32. So the intercept vector in real life in this approach will be 340 degrees heading. It cannot be sharper. So looking at my example right now, I pick the heading 040, 042. Let's make it 040. This would be way too steep. The problem with this, when the airplane reaches the course, you have to make a steep left turn to get on the approach course. And doing steep turns in IMC, not a great thing to have. But just for the practice sake, let's see what happens as I fly the airplane closer. Clicking on home, going back to the flight plan, we're still showing Intel as the destination. Now, what I want the GPS to do is to intercept the flower and show that I am on that leg going from Hobgu to flower initial approach fix. There is a way to do this manually. Go back in home, flight plan. You know that you are being routed to flower, and if you want to intercept the leg to the flower, then click on flower, and there is an option, activate the leg. Now, Hobgu to flower. When you do that, another important screen to be comfortable with is a default nav. Now, GPS is trying to put you on a leg between Hobgu and flower. Let's go back on the map, and we just blew right past it. Putting the autopilot on, airplane will spin around, and looking in default nav, what you're seeing on this screen is, see the pink line that is left of the center? That is your deviation. That's how far you are deviated off that course. That's your lateral navigation. In real life, you will be flying the HSI on a 650, but the information that's shown in this default nav screen is identical. Right now, it's pushing you back to that leg, Hobgu to the flower. I'll slow it down so we get more time to go through this. And as airplane is getting closer to the course, the line will center, you will turn inbound and fly the final approach course. And at that moment, there are other fields and settings that we'll go through, but I'll let this fly and shut up for a second, let you ask questions.
Can you talk about the altitude that should be flown there?
Good question. Yeah, so as we are approaching Flower, let's say, yeah, there you go. Here, so let's say we were cleared for an approach right about here, probably 5 miles from Flower, maybe a little closer. The altitude will be assigned by ATC in your clearance. One important acronym that I will be teaching is the PTAC: position, turn, altitude, and clearance. So up until you are being established, all the way to the moment when you are flying the approach itself, you are in the hands of ATC. They will tell you whatever heading, direction, altitude that they can. However, they cannot give you altitude below their minimal vectoring altitudes. So in this case, if we just look an approach and try to predict what do we expect, you see how the feeder route between Hobgo and Flower here has a 5,000 minimum. Chances are, if you're coming from this direction, you'll be given a maintain 5,000 until established. So the clearance, and sorry for the long answer, but I think it's important. The clearance will sound like 76 Foxtrot Alpha. You are 5 miles from Flower. They will clear you present position direct Flower. Then they'll tell you altitude maintain 5,000 until established, and finally cleared RNAV 31 left approach. At this moment, you are still maintaining whatever altitude they give you until you are established. However, that changes once you are flying the charted approach path. Then you read that minimal altitude that's charted and you fly that.
Okay, thank you. And that's, you're saying it's the minimal altitude, but you fly the minimum, so you should be at, and you can be higher, but you shouldn't be lower?
That depends on the clearance. So for example, if they said exactly this, maintain 5,000, or they may say descend and maintain 5,000, then you have to fly 5,000 exactly. Now, another option how they can clear you, they can say cross Flower at or above. In that case, just like you said, you can be higher, you can be however you want to be higher. So it does depend on the clearance. In this PTAC format, which they always follow, it can be a different type of altitude clearance, and that will tell you what to do.
Okay, thank you.
And it's mostly either you have to cross at the altitude or cross at or above altitude, or if you've been maintaining some altitude, they will just tell you to maintain that altitude until you are established. Now, that brings me to a next question. Well, what means established? I'll overlay this picture above the slide for a specific reason. See how the G5 has the pink marker left of the center. That would be exactly as what's showing on the simulator right now. Because if you look on the map, the path is left of our location. So when you see that on a G5, when you see the pink indicator, pink triangle left of center, that means the track that you have to intercept is to your left. That's exactly what you see on the map. And if I go back to default nav, the same indication is here. The pink course is left of your location. So right now the system is giving you guidance to intercept the leg between Flower and Nike. Does this make sense?
Yep, that's fine.
Okay. So we're getting in between Flower and Nike. Again, reminder, Flower is initial approach fix, Nike is intermediate. I'm starting the airplane to let it fly and join the approach. If I go into the flight plan menu, now that's what I wanted to show. Flower to the Nike, that bent arrow that shows from Flower to Nike. That means the GPS is sequencing itself, and right now it is flying you from the Flower to Nike, and then it will switch over to the next segment. While we are at this screen, depends on who flew this airplane before you. The number on the right side could be set up differently, and my preference is to have a cumulative distance shown. So while airplane is flying, I'm just quick switch to the map. Airplane is moving along at, let's make it 90 knots. It's slowly changing its heading to follow the approach. Look at what's happening to the distance. This one is changing. Currently, it is set to show the distance to Nike. So if ADC asks you what your location, you are 8.2 miles to Nike. But very soon, you will need to be talking to tower, or if it's an uncontrolled airport, you would like to know how far you are to the runway. And that's where my other favorite setting comes in. In this menu on a flight plan, if you click menu, then you go to data fields, and then you click on the data field that says this. You have a couple of options. My rather favorite option is actually cumulative distance. Now, let me add that as an option, go back and see what happened. Now, in this menu on the right, you see that we are 20 miles to the missed approach point, which is the runway. And we are already on the approach. So Alex, when you were asking who we'll be talking to, well, we definitely talking to a Portland approach, even 20 miles out on this approach. So useful setting. I think it makes a lot more value, brings a lot more value to have it in cumulative versus just a waypoint to waypoint. Okay, let's keep flying a little faster. Airplane is moving along. So imagine right now you are in a cockpit, you're flying the approach. You can probably switch between the screens depending on what you're looking for. At this moment, we are going from Flower to Nike. If you look at approach plate, now speaking of altitudes, Nike, and Alex, back to your question again. There are altitude restrictions for this non-precision approach. You were told to maintain 5,000 until established, for example, and right now you're going from Flower, initial approach fix here, to Nike. There are a couple places on this plate where you can see the altitude to follow. The plan view is showing 4,000 minimal altitude between Flower and Nike. And the same on the profile view. See the number 4,000 with a underline. That is at or above restriction. For some reason, GPS has 4,070, and we can change that, make it 4,000 MSL, enter. There you go. At or above. One of a smart thing to do is make sure that your flight plan matches your approach plate. It should when you load a recent current database in your system, but if it doesn't, then you better fix it. So Flower to Nike, we are flying at 4,000 feet. Once you get to Nike, then the next altitude restriction will be 2,000. And you see that the GPS has the 2,000 loaded in the settings. This screen alone will tell you what your altitude should be. When you cross Nike and you'll be flying towards Intel, you should be at or above 2,000 feet. Again, double check here on the profile view, there's 2,000. Yep, question?
Why would ATC tell to be above, and how much above should you be to still make the approach?
Okay, so that sort of rewinding back a little bit, back when we were still in some off-approach area, they can tell you to cross Flower at or above and give you a number. They would do that mostly for your comfort. They don't want to force us into a specific performance brackets like altitude unless they really have to. You can plan your descent however you'd like, as long as you meet their given restriction. So how much above? You don't have to be above a restriction that says at or above. You just have to be no lower than the 4,000.
Okay.
Who will be definitely unhappy is your DP, because if you look in ACS requirements, your allowance for altitude outside of final approach fix would be a plus or minus 100 feet. So either your DPE gives you an altitude to follow or ATC gives you altitude. You have to be plus minus 100 feet from that. Otherwise, that's a no-go. So we can stay with that. I would expect in the real world flying, that would be a good practice as well, to be within 100 feet of your approach altitude. But I'm a little unsure if this would cause ATC to be very unhappy if you are 300, 400, 500 feet above the charted altitude. Good question. I'll dig into this.
Okay, thank you.
Okay, so airplane is flying, and by the way, the simulator is running in real time. So if I'm flying 130 knots, all this time we've been talking that we've been still flying from Flower to Nike. We're 2.4 miles Nike, and I'm speeding things up just a little bit, but it doesn't happen instantly. It takes time. So at Nike is intermediate approach fix. Next would be Intel. You see right now that you are 2 miles Nike, 8.4 miles Intel. You can glance at the chart. There's 6.4 miles between Nike and Intel. That gives you some idea how much time to expect between Nike and Intel. Once you hit Nike, you can descend 2,000, and this is a good time to run before landing checklist. If you're flying exactly 60, then 6.4 miles would be what, roughly 10 minutes. Still, it's quite a lot of time. Now, next. Did I say 10 minutes? What did I mean? 6 miles, right? That's 60 on 6.
No, I think it should be 6 minutes now.
Right.
So 60 miles an hour is 1 mile per minute.
6. Yes, thank you. I knew something was odd. Okay, good. There you go. Well, that's a good highlight of doing math while you're flying is hard. So you need to have some of those quick formulas. Okay, moment. So 0, we're crossing Nike, and now we're switching to Intel. Now we're going direct Intel. And if we look at the map, the 650 will highlight the current leg. See how, moving this around a little bit. There you go. Zoom in.
By the way, your altitude is still 4,500.
Okay, I'll change that. So we just crossed. Go back, flight plan. We're going direct intel. Okay. And when we are going intel, I will put altitude 2000. This simulator doesn't really care what altitude you set here, but sure, just for the reality. What's important is, see how the line behind you is gray? The line in front of intel is white, but the active flag is pink. So the GPS will sequence that approach and highlight the current leg that you're flying, and the flight plan will show that right now we are going direct intel. Intel is the final approach fix. Again, countdown timer is happening, 5 miles to intel. Right now, simulator is pretending like it's flying 130 miles, knots an hour. No, 130 knots, which is nautical miles per hour. And you, in a general aviation aircraft, you have a lot of time to figure things out. But all this time, unless you're flying autopilot, you have to keep that pink needle centered. And altitude at 2,000 feet. And that's where another check ride warning comes in. Intel is the final approach fix. The moment you cross intel, you are not allowed to descend even a single foot below the altitude restriction. You get a -0 plus 100. So you can cross intel at 2,099 feet, but if you go below 2,000 crossing intel, that's a problem. From intel onwards, the next point is Zabuks. You have to be at or above the altitude given, but no more than 100 feet. In other words, -0 plus 100. Coming up on intel, going back to flight plan, 2.9 miles, 2.2 miles intel. At this moment, we are completing before landing checklist. Airplane is in final configuration for the final approach. It doesn't mean that you have to have the full flaps out, but you have to be in a configuration that you will keep all the way until you're ready to actually go in for landing. My advice, do not go full flaps. If you're flying a Cessna 172, maybe go flaps 10 or 20, but going full flaps makes it extremely difficult to do a go round, or let's say challenging, definitely doable, and you may be asked to do that. But if you look at the minimal descent altitude, you'll be still 456 feet above ground. That's plenty of altitude and time to deploy full flaps and start flaring for landing. So easier if you go and only add 10 or maybe 20 degrees of flaps. Coming up on intel, at this moment you are cruising along at, well, a little slower than 130, probably 85. And as soon as you cross intel, the next altitude restriction would be Zabuks at or above 880. Intel 0.2, 0.1, 0, and next Zabuks. At this moment, you cut the power and descend to altitude of no lower than 880. Again, remember, within that final approach segment, you are given -0 plus 100. So you can be anywhere between 880 and a 980 altitude when you cross Zabuks. Zabuks in 2.8 miles. Speed the things up a little bit. While we are, come on, traffic really. While we are waiting, Alex, back to you. Hopefully I was able to explain the altitude a little bit. What altitude will we be looking for once we cross Zabuks?
I'm 660, no less than.
Perfect. Yeah, exactly. And that's your minimal descent altitude. And notice if you look on the profile view, Zabax is 0.7 miles from visual descent point. That's where you would normally start your descent to landing, which is another 1.3 miles to the runway. All those numbers really help to know what to expect and how long to fly. Again, 0.6 miles is very short time, 0.7 miles. Crossing Zabax, in this case, it's a very small step down from 880 to a 660. Again, for the check ride, when you'll be flying this, don't go for the 660 exactly. Set the altitude bug 50 feet above 700 or 710 and aim for that 710 altitude instead of the 660. This way, talking from experience, way less chance to bust that altitude and screw the check ride. Because one thing that examiner has no, or probably in my opinion, has no flexibility is to forgive you deviation below that minimal descent altitude. Crossing Zabax, 0.7. At this moment, you'll be talking to the Hillsborough Tower. You'll be long transferred, and they would probably clear you for the approach. You're definitely, 2 miles away from runway on short final. If you still do not see the runway, if you're still in the clouds, then after Zabax, that is your last chance to descend and see the runway. 0.2 and 0.1. And 0. And now let's look at how the flight plan screen changes. There you go. Zabax to the missed approach point. Descend 710 feet. Carry forward until the missed approach point. Now, every approach is said to be concluded with a missed approach instructions. In this case, this direct climb 3,900 and hold at Dhaka. Landing, consider that a bonus, and most of your training flights you'll be going missed most of the approaches. There will be very few landings. So at this moment, you're 1.4 miles from the runway 31 left missed approach point. At 1.3, that is your distance from the VDP to the missed approach point. And if you don't see the runway at this moment, you're probably not landing, because you will not be in a stabilized descent if you see the runway this late. But the question is, when do you execute the missed approach procedure? And that will be one of the questions, is when exactly do you start the missed approach procedure? Anyone knows?
At the threshold. Yeah.
True.
Runway 31 left. Well, at that point, right?
I would say no later than. Can you execute it like right now, 0.5? Because you're saying, should I see nothing? It's 0.4. I'm way past VDP. Can you start the missed approach procedure?
I suppose, yes.
Yeah. The answer is absolutely yes. And in fact, anytime past the VDP, it will probably be a really good idea to start that, because you're probably not landing. Now, we are at the missed approach point, and that's another important screen. Once you hit the missed approach point, 650 will ask you, remain suspended or activate the missed approach procedure. If you're landing and if you actually see the runway and you're busy, you do nothing, it changes nothing. Or you can hit remain suspended, which means you're getting no more guidance. Important step, if you are going to fly the missed, you have to hit the activate GPS missed approach button. In this case, what happens, you will be given guidance to the hold. The G5 will give you vertical and lateral guidance to the hold, and will put you in the hold and will help you to fly the hold, and which will be a part of most of your approaches as you will fly them for training purpose. Okay, well, that's all I had. We made it to the end. Now let's see what other slides would be useful on precision approach. You know what, maybe just to put this on the screen, the slide that from experience, you really have to know this one, 91-175 Charlie. So let's say you are at that missed approach point. What do you need to have to descend and land? 3 important conditions. You are in position to land, and as we just discussed, if you're way past VDP, even if you see the runway, or maybe DPE says take off your hood, you are almost at the missed approach point, and you say, oh yeah, I see the runway. Should you be landing? Probably not, because you're probably not in a position to land using normal flight maneuvers. Second, flight visibility. On our approach plate, we had a requirement of 1 mile flight visibility. Looking outside, you have to make sure that flight visibility is no less than what's prescribed on the plate. And then the hard one is one of those 10 visual references that are distinctly visible. Paint, pavement, or lights, either on a threshold or touchdown or runway or any other, like 31 left has runway identifier lights, rails, has poppies on the left. Any of those or a group of those indicators would be sufficient to land. So 91-175 Charlie, really important to know and remember, and that's one of your favorite chapters. Okay, I think that's a good conclusion. That's been almost full hour. Will look up a couple questions, get this posted, and that's all I have for today. Any questions?
So what if the traffic was real? Like you do an instrument approach and it tells you there's traffic at 1 o'clock.
Exactly. Well, if you are in actual instrument meteorological conditions, you see nothing. This could be a false alarm. Right. The first thing you need to do is ADC, I'm getting traffic notification. Help, right? Is it possible that they have made a mistake and somebody else is flying in IMC and in close proximity? Well, I hope not, but in this case, if you don't have a visual on the traffic, don't fly off course. Talk to ADC, let them know what you see. This could be malfunction, or maybe they will give you instructions. However, if you are on instrument flight plan and you see with your eyes an actual traffic that becomes a danger, you have full authority given to you by 91.3 in CFR. You have full authority to do whatever it takes to avoid the accident. So if that traffic is real and you see it, you deviate up to whatever you need to do to make sure that no one gets killed.
Cool.
A different question, Dmitry. Maybe you will cover it in the future lessons, but how do you do a go-around in IMC?
Good question. Yeah, well, wait, not for today. I'll save it for next lessons, but there is some theory and a lot of practice, definitely. Yeah.
Okay.
Save the patience. We'll get there. I will be repeating some topics, even the ones we covered, and that's an important piece of the training, definitely. Well, let me stop the recording. That was good.